Hi everyone, I'm Kathlene Laresma from VCS 2B, and I am here in front of you to explain how the code works. This code serves as an introduction to solving the traveling salesman problem using an approximation algorithm showcasing the process of creating a graph, assigning age, weights, computing an minimum spanning tree, generating a tour, and visualizing the results. The first the first comment of the code is defines a function named travel salesman problem approximation that takes a graph approximating the traveling salesman problem solution using a minimum spanning tree approach. This part of the code defines a function that, given a graph, calculates the minimal spanning tree using Kruskal's algorithm and stores the ages of the MST in a list. The MST will be used in subsequent steps of the algorithm to approximate the TSP solution. The second comment is this part of the code is responsible for creating a tour by traversing the minimal spanning tree obtained earlier MST. This part of the code generates a tour by performing a depth first search pre-order traversal on the graph, starting from the first node of the first edge in the minimal spanning tree. The resulting tour nodes list represents the order in which the nodes are visited during the tour. The third comment, this part of the code finalizes the TSP tour by adding the starting node to the end of the list of tour nodes. Also, this part of the code ensures that the TSP tour is closed by adding the starting node to the end of the list, and the functions returns the finalized list representing the approximate TSP tour using the minimum spanning tree approach. The fourth comment, this line checks whether the Python script is being executed as the main program or if it is being imported as a module. If name equals name, a special variable in Python that represents the current module's name. Main, the name given to the Python script when it is executed directly. The condition checks if the script is the main program if it is being run directly. The intended code following this condition is executed only when the script is run directly, not when it is imported as a module. This is the common pattern to include example usage, test, or specific actions that should occur when the script is executed on its own. The if name equals main statement ensures that the code block beneath it is executed only when the script is run directly, allowing for specific actions or examples to be provided when the script is used as the main program. The fifth comment, This part of the code creates a comprehensive graph and representing cities where each city is a node, and there is an edge between every pair of cities. Additionally, it assigns random edge weights distances to the edges. This part sets up a simple scenario with a complete graph representing cities and assigns placeholder edge weights. For practical use, you would replace the assigned edge weights with actual distance values between the corresponding cities. The sixth line comment. This line of code calls the TFC-TSP approximation function to obtain an approximate solution to the traveling salesman problem. Using the minimum spanning tree algorithm. The TSP approximation function, as defined earlier in the code, takes a graph as input and returns a list of nodes representing an approximate TSP tour using the MST algorithm. Also, this line of code initiates the TSP approximation process on the graph G and stores the resulting tour in the variable tour. The TSP approximation function calculates the tour based on the minimum spanning tree obtained from the graph. The seventh line of the code prints the approximate traveling salesman problem tour that was obtained using the minimum spanning tree algorithm. The message indicates that the printed list represents the approximate TSP tour. Tour is assumed to be a list of nodes representing the order in which cities are visited in TSP tour. For summary, this line of code displays the approximate TSP tour in the console by printing the list of nodes obtained from the MST-based TSP approximate part of the code. This part of the code is responsible for visualizing the graph in the approximate traveling salesman problem tour using matplotlib and networks. For summary, this code segment visualizes the complete graph with node levels and highlights the edges representing the TSP tour. The plot is displayed using matplotlib, providing a visual representation of the approximate TSP tour obtained through the minimum spanning tree algorithm. And to run this code, this is the result. Approximate tour 0, 1, 2, 3, 4. And that's the code works. Thanks for watching.